Hello everyone, my name is Ekaterina Savchenkova, and today we are going to talk about real numbers. I'm going to turn off my video because I want more space, and it's really hard to write down on the board when it's like vertical, okay? But I'm still here. Give me a second. Let me turn it off. Okay guys, so real numbers. Well, we are going to start with drawing a picture of number sets, and they're going to look like nested dolls. So we're going to start with natural numbers. Natural numbers are numbers we use for counting. So I'm going to write down natural numbers. Give me a second. Natural numbers. And there are numbers like 1, 2, 3, and infinitely many of them. We don't have any limit for them. I'm going to round them, and it's going to be one set of natural numbers. So all natural numbers are sitting here. Though there are infinitely many of them, they still can be kind of called like by one name and sitting in one set. Now, we are going to add to natural numbers 0, and that's going to make whole numbers. 0. I'm going to leave off whole numbers. And that's going to make a bigger set. A little bit bigger, by one number actually. Yeah, it likes to turn off my circles, ovals. Now, if we add all negative numbers, if you take all natural numbers and kind of add a minus to everyone, every natural number, we're going to have integers. So I'm going to put additional numbers like -1, -2, -3, and infinitely many of them, and label it as integers. Integers or integer numbers. My pen is not working very well. Sorry. Yes, I'll try to fix it, guys. Let me stop recording for a second and see how I can fix it. Okay, guys, we stopped at integers. I fixed a little bit my pen. Integers are all negative numbers, 0, and all positive numbers, which we use for counting, right? What other numbers that we can combine out of what we have already? Well, we can kind of take a natural or integer number and divide it by another integer number and get a fraction, something like 1/2, or maybe -3/5, or something like this. So when you take two integers in the form of m/n, and both are integers, we are going to call these numbers rational numbers. Still not working. Okay, sorry guys. Maybe I should just enter a text over here. Let me erase it. Rational numbers. Okay, guys, I'm going to, no, I don't want to do this. I want to just move this. Edit it. Come on. Okay, well, rational numbers are all fractions which we make from integers. I'm going to circle them with a different color. Well, mostly, guys, we are going to deal with rational numbers, but there are also numbers which cannot be represented as a fraction of two integers. And such numbers are like pi, or, for example, a square root of 2, or cubic root of 3, well, let's say cubic root of 3. These numbers are called irrational numbers. And I'm going to circle them by a different kind of circle because irrational numbers are making up their own set. And numbers from this set cannot be represented as a fraction of two integers. I'm going to put them irrational. What kind of rationals are here? Irrationals. Well, again, I think I'm going to just make a text irrationals. Irrational numbers. Okay. And I'm going to, well, let me put it here. And I want to actually kind of move it to irrational numbers. Okay. So irrational numbers. Now, if we unify these two sets of rational numbers and irrational numbers, and again, definition of irrational numbers that we cannot represent it as a ratio between two integers. If we unify them into one set, we are going to get complex numbers. Not complex, real numbers. And these are going to be the numbers we are mostly going to deal in this class, real numbers. Real numbers are all numbers we are using like for measurements, for counting. There can be decimals, can be represented as fractions. Now, guys, there is one more set of numbers which is bigger than real numbers. And we are going to touch it a little bit in this class, and that's called complex numbers. So if you add to the set of real numbers, imaginary numbers, let me do the text over here, imaginary numbers. Let me move it, imaginary numbers. If we add additional set of imaginary numbers, let me kind of make it blue, for example. What are imaginary numbers? They are kind of real numbers, but they are multiplied by imaginary unit. Well, I'm going to multiply the b, and b is a real number, real number. Okay, so we are going to unify these two sets into a like a biggest set we can have, and the biggest set is going to be labeled as complex numbers. Well, you see it's a whole map, and here we are going to have complex numbers. Numbers. Okay, so that's all about like different sets of numbers. In the homework, I placed several questions to identify like to which set the number belongs. You know that lots of numbers here are going to belong to several sets. For example, you consider number 3. It belongs to natural numbers, whole numbers, integers, rational numbers, real numbers. It does not belong to rational numbers. It does not belong to imaginary numbers, but it belongs to complex numbers. It's a also a complex number. Let me write down complex numbers better. Okay, let me erase these complex numbers and do the text here. Complex numbers. Okay, good. Oh, no, so sorry, I want to do this. I want to do this. Just want to set it over here. Complex numbers. Okay. Well, it's just like going to be exercise on identifying the number. For example, if somebody gives you a square root of 2, it belongs to irrational numbers, and also it belongs to real numbers, but it does not belong to imaginary numbers, but it belongs to complex numbers. Look at this map and kind of identify the number, okay? Well, I think I'm going to stop my lecture and fix my pen again. Something does not work well. I cannot work like this. Give me a second, guys. Okay, guys, I just got a new pen and we can continue working on real numbers. So right now I'm trying to talk about properties of real numbers. You know many of them, so I'm not going to be very long explaining like stuff, like basic properties, but there are some properties which are going to be good to review. So we have some properties for addition and multiplication, which are commutative, associative, and distributive properties. So I'm going to start properties. Let me make it a little bit bigger. Properties. So number one, commutative. Commutative property is that a plus b equals b plus a, right? So actually, you can add in any order and subtract in any order. Well, also for multiplication, you can also switch terms, mean factors. Okay, so 2 plus 3 is equal to 3 plus 2, and also 2 multiplied by 3 is equal to 3 multiplied by 2. We check these properties by literally counting what is happening. Number two, associative property. Associative property is about parentheses. So if you have 3 terms added, it does not matter how you place parentheses in this, like, addition means that order of operations in several equal operations does not matter. So you can add a plus b and then add c to the result, or you can actually add b plus c and then add a to this result. Same works for multiplication. If you multiply 3 factors, you can multiply first 2 and then multiply them by factor number 3, or you can multiply second and third factor and multiply the result by first one. So associative. Sorry, a little bit. And distributive property. Let me do the property first and then label it. So distributive property is mix up between addition and multiplication. So if you have a multiplied by b plus c, you can actually open this parenthesis and multiply a by b, and then multiply a by c, and then add the results. Same property is going to work if you move b and c in front of a. So if you have b and c in front of a, you still can do multiplication. Just multiply b by a and multiply c by a, and then add the results. And this is distributive property. Well, out of these properties, we're going to mostly use distributive property. And remember how we multiply two binomials. Example, let's do an example. So for example, you multiply 2 plus x by 5 minus y. Well, how do we kind of deal with this operation? Well, first, we are going to multiply, for example, 5 by this parenthesis and y by this parenthesis. Looks like we are going to use line number 1 out of here, out of number 3 property. So we are going to have 2 plus x, it's kind of our a, right, multiplied by b, and also 2 plus x multiplied by negative y, right? So we use the line number 1, we multiplied b by a and c by a. So we have ba and ca. Now we are going to use line number 2 and open this parenthesis, and that's going to be 2 by b. Well, we multiply now b is going to be the same here, and we multiply c and b, like a, c and b. So we have b and x multiplied by b. And for the second one, minus y multiplied by 2 is going to be minus y multiplied by 2. We are going to simplify it later. It just for right now, I'm just going to write it down. And else multiplied by negative y. Well, of course, you can simplify simple stuff here, right? That's going to be 2b. No one is writing down the 2 multiplied by b, right? Also x, b, and you can put b first or x first, and then minus 2y, right? For this term, you can kind of use minus as, like, take it outside of parentheses, and minus xy also. So what we see over here is a way to multiply two binomials. You also can use FOIL, which is going to give you the same result, just like the way of using the properties. Okay, more interesting are properties of fractions. So let me scroll it up. Properties of fractions. What are properties of fractions? Well, I'm going to start with some kind of simple properties. So if you multiply two fractions, a over b, by fraction c over d, what you can do, guys, you can multiply numerators a by c and multiply denominators b by d. It does not work for addition. So works only for multiplication. So if you have a over b plus c over d, you will need to bring it to common denominator. Works only for multiplication. Example, for example, 2 over 3 by 5 over 4. Sorry, sometimes I have automatic triangles. It's going to be 2 multiplied by 5 divided by 3 multiplied by 4, which is going to be 10 over 3 by 4 is 12. And if you wish, you can do cancel 2 and 2 from numerator and denominator. For right now, it's not necessary, but actually you can do it. Simplify the fraction. Okay, property number 2. Property number 2 is going to be about division. If you have a over b divided over c over d, what you do to divide by a fraction, we multiply by reciprocal fraction. Reciprocal fraction means that you flip over this fraction. You put numerator on the top and denominator on the bottom. So instead of division, we have multiplication and flip it over. And then we follow rule number 1 and we multiply a by d and b by c. Example, 2 over 3 divide over 5 over 4. So it's 2 over 3 multiplied by 4 over 5. I flipped up second fraction, and then you just multiply 2 over 4, and that's going to be 8, and 3 over 5 is going to be 15, and there is nothing to cancel here. Okay, now we are going to talk about addition. Looks like addition is supposed to be come first, but actually it's a little bit more complicated. So if you have a over c plus b over c, so your fractions have same denominator, we are just going to add numerators. It's like you have 2/3 and 1/3. How many thirds you have in total? Okay, 3/3. I'm going to kind of explain it a little bit like lower. Example, you have 2/3 plus 1/3. What does it mean actually? 2, 1 over 3 plus 1, 1 over 3. Now we can take outside of parentheses using the rules which I described above and kind of write down 2 plus 1 by 1 over 3, right? And here we have 3 by 1 over 3, which is going to give us 1 eventually. But again, this is simplifying part. Important part for us that we can add numerators. You see, numerators are added, denominator is staying. And what is going to happen if denominators are different? Here, denominators are same, so it was easy, right? What if denominators are different? We are going to have a over b plus c over d. So different denominators, b and d are not equal, different denominators. How do we add them? Well, we are going to reduce it to rule number 3 by making denominators same. How can we do this? Well, for example, here for the same denominator is going to be common denominator b, d. D is missing, right? What we can always do with a fraction is multiply it by 1, which can be like ratio of any two numbers. For example, 3 over 3 is 1. So what I'm going to do, I'm going to write down that a over b, and here is missing d, right? D is missing. So I'm going to multiply it by d over d plus c over d, and here is b missing. So I'm going to multiply it over b by b over b. So again, I'm not changing fraction by multiplying by d over d because it's equal 1 and also equals b over b equals 1. But now if I use rule number 1, a multiplied by d and denominator is bd plus c multiplied by b and denominator is, I'm going to switch d and b because I want to make it like eventually same. So b multiplied by d, d multiplied by b, same denominator. I can use rule number 3 and just add numerators. A multiplied by d plus c multiplied by b. And same denominator, well, we remember that b multiplied by d and d multiplied by b is same. So I'm just going to write it down as b multiplied by d. Well, let me kind of give you an example of this. I think I'm going to scroll it a little bit up and give example below. For example, 2 over 3 plus 5 over 4. We see that common denominator is here 3 by 4, right? So I'm going to write down 2 over 4, 3 over 4, multiplying this fraction by 4 and the top and the bottom, plus 5 over 4, and 3 is missing here for the second fractions, 3 over 3. Now, denominator is same, 4 by 3, 4 by 3 is 12, right? And for numerators, I have 2 by 4, which is 8, and 5 by 3, which is 15. I'm going to add up numerators, and I'm going to get what? 23 over 12. Well, 23 over 12, you can simplify it a little bit, separating out 12 from here, right? 23 can be represented as 12 plus 11, right, over 12. And we can kind of divide each part by 12 and get 1 plus 11 over 12. Well, again, sometimes it will be necessary to do, sometimes not, but this is a way to simplify fraction a little bit, separate the whole, the integer part of the fraction. Okay, and next, number 5. I actually already used number 5 without telling you. So what is going to happen if you have a fraction where you have a multiplied by c and b also multiplied by c? We know c and c is just 1, right? So we can actually cancel it from numerator and denominator and have fraction in simplified form a over b. For example, if you have 2 multiplied by 5 and 3 multiplied by 5, you can always cancel 5 here and have 2 over 3. Well, it's kind of inverse of the operation of multiplication by 1, right? And the last property, which is rather a statement about two fractions being equal, the last property. If you have two fractions equal, fraction a over b equals c over d, two fractions equal, well, you can always multiply both sides of this equation. This is equation because it has equal sign by by bd this side and by bd this side, which is going to bring you canceling b to d multiplied by a, and c multiplied by b, d is going to be canceled here. But normally, guys, we are going to skip the step of multiplying, and instead of that, we are going to do crisscross multiplication. So if you have a over b equals c over d, you multiply denominator of the second fraction by numerator of the first, and same operation for this. And of course, you are going to have the same result, b multiplied by c, like we are over here. Over here. So that was a little explanation of why we are doing this, but normally we are just going to do crisscross multiplication. Okay. Let's do a little example of multiplication. Let me change the color. I'm kind of tired with red. So, like, guys, can you do next thing? I'm going to ask you sometimes to do self problems. Self problems means that you can practice a little bit on your own and then listen to my explanation. So why don't we add two fractions, 5 over 14 plus 3 over 8. I'm going to let you stop my video, do this by yourself, and then I'm going to explain it. So I'm going to give you a little pause, like 3 seconds, and then I'm going to explain solution. But in this pause, I want you to actually kind of stop your video and try to do it on your own, like if you still remember this or not. Okay, so that's going to be the pause, and 1, 2, 3, I'm going to start explaining it. Okay, so how do we add this? So it's going to be a solution. Again, my suggestion is to try it on your own first and then watch solution. What I'm going to do, guys, I'm going to consider denominator. We need to find the common denominator between these two fractions. And generally speaking, guys, you can just use common denominator as a product of these two fractions, but number is going to be kind of large. And it's going to require canceling of the stuff after. So it's better if you find the least common denominator, or the smallest denominator which can kind of satisfy both fractions. How we do this? We factor both denominators. So my first denominator is 14, which is actually 7 multiplied by 2. And I cannot factor it any further because both are prime numbers. My second denominator is 8, which is 2 by 2 and by 2, right? 3 times multiplied 2. I see that, well, these two and these two are common for them, right? But these twos are extra. What is missing for this fraction is going to be like extra 2 twos. So I'm going to multiply this fraction by 4. And that's going to give me 2 twos extra. Now, what is missing for this fraction is going to be 7, because it already has 2, and there's 2 twos, and that's 7. So that's going to be my common denominator. And for this one, we already have 2 by 2 by 2, so we are missing just 7. So I'm going to multiply this by 7. So what we have, 5 multiplied by 4 plus 3 multiplied by 7, and the common denominator is going to be 7 by 2 by 2 and by 2. So literally we multiply all prime factors which are different for each fraction. So we're going to satisfy like both fractions. So this fraction is satisfied because it's 7 by 2, and this fraction is satisfied because it's 3 twos. Now 5 by 4 it's 20, and 3 by 7 is 21, and in denominator we have something like 2 by 7 by 4. We have 41 divided over what we have, 28 by 2, 50, I think 6. I don't think that we can cancel anything from numerator and denominator here, so it's going to be our final answer. Okay. Well, guys, I want to give another example. Sometimes we are going to do inverse operation. Inverse operation means that instead of adding two fractions, we are going to write down one fraction into two fractions. Well, it's not like we are going to use it very often, but we'll need to know that we can do this, because sometimes people know how to add two fractions, but they don't know how to break one fraction in two. Imagine that we have a fraction which looks like 2 plus 3 over 6. 2 plus 3 over 6. Well, it was 5 over 6, but I represented 5 as 2 plus 3. What we actually can do, guys, remember that this fraction is probably addition of two other fractions, like somewhere here. Let me show you where, like somewhere here. But this is like 6, and this is 2, and this is 3, right? We can always represent it back into two fractions as 2 over 6 plus 3 over 6. And 2 over 6 can be canceled by 2, right? So it's going to be 1 over 3, and 3 over 6 can be canceled by 3, and we have 1 over 2. We're not going to do this operation very often, but sometimes we will need to do it, and we'll need to know how to perform it. Okay, now, guys, we are going to move to interval notation. Interval notation. Let me change the color again. Blue. Interval notation. So what is interval notation? Well, guys, we are going to draw a number line. Number line goes from the left to the right. Has some 0 over here, right? What is interval notation? On number line, you can shade an interval, and interval notation is going to just kind of describe this graphical way into more mathematical way. I'm going to, for example, shade the region between -5 and 0. Again, just arbitrary region, just for show. And shade the region starting with 3 and going to infinity. Well, guys, first, we are going to describe the region between -5 and 0. You see that this region has black circles at the end, means that these points are included into the interval. When you write down something included, you use square brackets, so it's -5. You write down the left end of the interval first, and then the right end of the interval. And if your point is included, you are going to put square bracket too. What is going to happen for this interval? First, we see empty circle. Empty circle means that you don't include point 3. So we are going to write down point 3 as the left side of the interval. Right side of the interval is what? Well, it's actually infinity because we don't have any limiting number here. You're going to write down infinity. Infinity will always have parentheses. It's like open side of the interval. Okay, so intervals with square brackets are called closed. Intervals with parentheses are called open intervals because they are not including the boundary. Okay, well, we are going to use this interval notation to give the answer for some problems. For right now, let's consider problems which can bring you to interval notation, and they are going to be problems about absolute value and distance. Okay, absolute value and distance. Well, first, what is absolute value? Let's say absolute value is a distance from number A, distance from, from number A to the origin. Well, I'm not going to say origin because here we don't have origin. We are going to just have number 0, okay? Here, because in one dimension, we don't have origin, we have 0. Well, what does it mean? If you have a number line, and for example, here is 0, and you have a point 5 over here. So what is absolute value of 5? Oh, come on, don't turn it into the... I want to go back. Give me this square. Okay, I'm going to erase it. I want to have the square. I wanted to have absolute value actually. Okay, square is going to stay, I guess. Cannot erase it. Let me change to eraser. Yeah, square, I don't want to erase. Okay, guys, I'm sorry. I'm going to deal with the square a little bit later. For right now, what is absolute value of 5? Square. That's, I don't want a square. Okay, that's a way to remove the square. I was not breaking it up. Okay, so absolute value of 5. What is distance from 0 to 5? You take a ruler. No, I don't want to make my ruler triangular. You take a ruler, and the ruler has some 0, 1, 2, 3, 4, 5. You put it here, measure it. Okay, 5 units. Okay, now you have a number -5 on this side, and you place the same ruler, measure the distance, and it equals 5 again. So absolute value of -5 equals to 5. Okay, so that's like how it works. More generally, we can write down that absolute value of A equals to A if A is greater or equal than 0. Positive numbers are just going to give the number itself, right? Negative numbers are going to give the number which is the same with minus. For example, if you have -5, absolute value is 5. So it's like you drop the minus. Well, in math, we don't really drop the minus. We add extra minus in front. So this is, I'm going to write it down. It's like minus -5. So this is minus describing the minus. Well, this is definition of absolute value as a function. Okay, properties of absolute value. Well, there are not too many properties. Actually, there is a property of multiplication and the property of like triangular property. So first property, multiplication. If you have numbers A multiplied by B, you can actually separately take absolute value of A and absolute value of B and multiply them. So it's kind of distributive property. Triangular inequality, we're not going to use it a lot, but sometimes we will use it. So if you have a sum of two numbers, it's always, absolute value of it is always going to be less than a sum of absolute values. You see the difference? For a product, they are exactly equal, right? For sum, actually, this is going to be always bigger than this. Okay. Well, I don't know. Example. Well, let's say absolute value of -5 multiplied by 3 is equal to absolute value of -5 and absolute value of 3. And we actually have 5, right? We already know that absolute value of 5, negative 5 is 5, and absolute value of 3, because it's positive, is 3, so it's 15. And if you calculate actually number first and write down minus 15 here and take absolute value of it, you're still going to get 15, right? We drop the minus according to the formula, and that's going to give us the result. Example for addition. If you have minus 5 plus 3. So what is actually minus 5 plus 3? Well, minus 5 plus 3 is negative 2, right? We remember. And absolute value of negative 2 is 2. And we know that 2 is going to be less than absolute value of 5, minus 5, sorry, plus absolute value of 3, because absolute value of minus 5 is actually 5, and 3 is 3, and that's going to give us 8. I'm trying to check this inequality. Of course, we see that 2 is less than 8. Why does it happen actually, guys? Here, plus and minus are kind of working in opposite direction, right? Minus is moving you to the left and plus is moving to the right, and the result is actually minus 2. It's not just a product with minus. And the sum of each number separately, if you take absolute value, is going to give you something bigger. It's not necessarily always going to be bigger, but remember we have equal sign here. For example, if you have 1 plus 2 here, absolute value is, let me give you this example, 1 plus 2, and absolute value of 1 plus 2 is 3, right? And you know that absolute value of 1 plus absolute value of 2 is also 3, just because it's absolute value of each. Here we are going to have equal sign. So equal happens usually when A and B are both positive, or they are both negative actually. When they are having different signs, that's going to be inequality. Okay. I think what we can do, last thing I want to describe is the distance between the point on the number line. And I think we're just going to have maybe one example on absolute value. So the distance between 2 points on number line. Distance between, too many E's, I guess. On number line. Okay, so I'm going to write down distance between points A and B. Right, it's the, not supposed to be B, equals absolute value A minus B. Or you can do B minus A, does not really matter. Well, I think the book actually thinks a B minus A. I'm going to write down B minus A, but absolute value does not really care whether you kind of have B minus A or A minus B. What I'm trying to say, guys, if you have point A on number line, A and point B on number line, what is going to happen if you just measure the distance with a ruler? Well, that's absolute value of difference B minus A. Why do we need absolute value? Well, sometimes B minus A is going to give you a negative number, but we know that distance is always positive. Distance is something what you measure with a ruler, and it's always going to be positive. Well, let's try to kind of measure the distance between, for example, distance between numbers 2 and 4. What it's gonna be? 2 and 4. According to my formula, it's 4 minus 2 absolute value, which is 2, right? Because 4 minus 2 is 2. I'm going to draw a little picture. That's 2, it's 4. Well, you kind of know that this distance is 2 units, right? Just look at the number line. Now, another distance. Distance between minus 5 and minus 1. According to absolute value inequality, it's minus 1 minus minus 5, right? Let's do first addition. So minus 1, minus and minus canceling, and plus 5. 5 minus 1 is 4. So absolute value of 4 is going to give us 4. Now let's draw the picture just to make sure that everything is correct. That's minus 5. Minus 4, minus 3, minus 2, minus 1, right? We'll need to measure this distance. Well, we have exactly 4 squares, so the formula works. The last example, just one more distance, and I think we will be done with it. one more distance. Distance of -3 and 5. How do we measure distance when it looks like this? Well, again, it's 5 minus -3. And in this case, we have what? 5 minus and minus cancel, and that's +3, which is going to give us 8, right? 5 plus 3 is 8. Why does it happen? Well, let's say -3 here, -2, -1, 0, 1, 2, sorry. 2, 3, 4, 5, right? We need to measure this distance. Well, how many squares we have? 1, 2, 3, 4, 5, 6, 7, 8. Exactly 8 squares. Yeah, guys, if you accidentally forget what to subtract from what if you think you subtract, like instead of finding distance -3, 5, you find the distance between 5 minus 3. Is it going to be equal? Well, you know, the ruler does not know which number you count first, which number you count second. You just put the ruler between and kind of mark position. Distance 5 and 3 is going to be 5, no, 3, sorry, according to our formula. Sorry. It's going to be -3 minus the second one, 5, right? And -3 minus 5 is -8, right? And the absolute value of -8 is just 8, the same number. So actually it does not matter distance between -3, 5, distance between 5 minus 3, and it does not matter the order, the numbers you subtract. The major thing is to remember that it's subtraction, and don't forget about minuses in front of the numbers. Okay, well, that's all for this lecture, and I want you to do the homework exercises. They're not supposed to be too long. I give a little bit more than 10 exercises, but you always can do extras in between, because I don't really know, like for some people it's a review, for some people they learn some new stuff. So, you know, judge yourself. If you wish to kind of do more problems, you always can do problems, all problems in a block. For example, I assigned 1 problem out of 6 in a block of 6 problems. You can always do more problems from this block. You can do 2 problems, 3, or even all of them. Okay, so don't limit yourself to number of problems I assign if you don't understand clearly how the problems are working. Okay, and see you in my next lecture.